This documentary describes the making of a directly heated triode, according to the first patents filed by the inventor Lee de Forest at October 17, 1906. In 2006 we celebrate a triode centennial. The place to celebrate this is the 7th European Triode Festival, this time organized in the Netherlands. The intention was to make a reproduction with the simplest means available, not to make a high-performance triode. This project could only succeed with the great help of Noël van Mossevelde, Gerard Stoer, Wil van Hoppe, Fred Westerterp, Ton Hooghout and Mark Meubissen. And last but not least, Philips Lighting, who not only supplied the materials, but also made it possible to use their prototype lab in Eindhoven. The essential parts of the tube are the filament, which also serves as a cathode, the grid, the anode, the base and the bulb. The preparation of the process consists of the cleaning of the anode and the grid, the assembly of the subparts and the mounting of the parts to sub-assemblies. The filament we use stems from modern fluorescent tubes. Its efficiency is increased by the use of barium, strontium, calcium oxide. In addition, we use phosphorus, which actually serves as a getter. A getter will absorb remaining gases that are still present after the vacuum pumping process. The activation of the getter takes place later in the process. The grid made by the forest consisted of a folded wire. We decided to use a mesh of pitched wires about 0.6 mm folded around the filament. The anode consists of a piece of chrome iron of about 4 square centimeters. All metal parts are heated up to about 1000 degrees Celsius to burn out gases. The filament and grid are mounted upon a support. This support also stems from fluorescent tubes. It has 3 external connections. 2 of these are for the filament, which also serves as the cathode. The third connection is used as a stud to support the grid. The grid is electrically connected with an extra wire. This wire leaves the tube through the exhaust tube and will be sealed later, prior to pumping the tube. The anode is supported by a stiff wire that sticks through the side of the bulb. The support also serves as electrical connection for the anode. The bulbs we use are taken out of running production of A60 type light bulbs, and an extra exhaust tube is connected on the top of the bulb, as we cannot use the tube sticking out the base later. Once all subparts are assembled, we can start production. Prior to that, all parts are cleaned to get rid of grease and other dirt. We use methylated spirit. Now the bulb and the anode are prepared, they can be melted together. First the bulb is cut to length. Then the base is put in. The glass is slowly heated up, and finally the 2 pieces are fused together. Once the bulb is assembled, it needs to be evacuated and the cathode needs to be activated. This is done in 3 steps. Prior to that, the tube is connected to the vacuum pump using the exhaust tube that is connected on the top of the bulb. The first step starts with vacuum pumping. Any humidity in the tube immediately disappears. The whole tube is then put into an oven and heated to about 400 degrees Celsius. The vacuum pumping process continues. By heating all elements, remaining gases are released and exhausted. This is seen from an initial drop in the vacuum level. The final stage is the activation of the cathode by slowly increasing the filament voltage. The pumping continues until we achieve a vacuum of about a millibar. Finally, a high voltage is applied across the tube. The grid is connected to the anode, so the tube acts as a rectifier. With an increasing high voltage, we see an increase in current. To finish the production process, the exhaust tube is sealed. The triode is now ready for use.